Hello, welcome to the 8th class of this course. So in the past few classes, what we have learned is basically how to find out a power series solution of a differential equation at some point. Now what we will do is uh, we will take some special differential equations and we will solve them and study different properties of them. So one such differential equation is Legendre differential equation. Okay, so let me write it. Legendre differential equation. That is 1 minus x square d2y dx2 minus 2x y dash means dy dx plus L times L plus 1 times y equals to 0, where L, these are some constants. Okay, so why this Legendre differential equation is so important? If you solve hydrogen atom problem using the quantum mechanics, that means Schrodinger equation, so there will be separation of variables. So you will separate out the radial part, you will separate out the angular part of the differential equation, and in the angular part you will see, you will get this Legendre differential equation. Okay, so how the angular distributions let me polynomials. So how the angular distribution of the atomic cloud will look like, so that will be given by this Legendre differential equation. So solving this equation is then very important to understand how the how the electron cloud will look like in 3D. Okay, so let's solve it. So we will find a solution around x equals to 0, and you can see, so this is the px, so this is the px, this is the qx, and this is our rx, and you can see that px at x equals to 0 is 1, right? So that means, or rather you can see that, okay, qx by px at x equals to 0 is basically 0, and rx by px at x equals to 0 is L into L plus 1. So both are analytic. What I'm trying to say is, both of these ratios, these are analytic at x equals to 0. That means x equals to 0. Okay, let me write it here, that x equals to 0 is an ordinary point. X equals to 0 is an ordinary point. Okay, for this differential equation, for this Legendre differential equation. So in that case, the solution we will assume is yx equals to sum over an x minus x naught to the power n, but x naught is 0. We are trying to find out the power series solution at x equals to 0. So this x naught is 0. N equals to 0 to infinity. So what now our goal is to find out this ans, okay, and we will follow the usual procedure, right? So the third term is so let me write it, L into L plus 1 y, which is L into L plus 1 sum over n equals to 0 to infinity an x to the power n. This is the third term, okay. Now the second term is minus 2y x y dash, okay. So for that I need to find out y dash. So what is y dash? Y dash x is sum over n equals to 0 to infinity an x to the power n minus 1, okay. But n starting from 0, so the 0th term, if I put n equals to 0, then you can see this term is 0 because n sitting here, so this n sitting here. So the 0th term contributes nothing. So in that case I can start this series from n equals to 1. So n x to the power n minus 1, okay, and there is a x multiplied with it. So the second term is basically minus 2x y dash, which is minus 2 sum over of n equals to 1 to infinity n x to the power n, because here x has a power of n minus 1 and there is 1x multiplied with it. Sorry, yeah. So this is the second term, and now let's look at the first term, which is this one. So for that we need to calculate y double dash. So let's calculate that. So y double dash x equals to sum over n equals to 1 to infinity, okay. So we need to take ddx of this term, okay. So it is n times n minus 1 n x to the power n minus 2. Now you can see that n equals to 1th term, if I put n equals to 1, in that case for this factor sitting here it will be 0, the whole term will be 0. So n equals to 1th term, it contributes nothing in the summation. So that means I can start it from n equals to 2 to infinity n minus 1 n minus 1 an x to the power n minus 2, right. So this is our y double dash, and now the first term is 1 minus x square times y double dash. The first term is 1 minus x square times y double dash, okay, which equals to 1. So 1 times this factor, this summation, okay. So which is just this summation, which is n equals to 2 to infinity n into n minus 1 an x to the power n minus 2 minus x square times this term, okay. So if I multiply by x square, so then all other terms will remain the same, that is n equals to 2 to infinity n minus 1 an, and instead of x to the power n minus 2 I will write x to the power n, right. Good. Now So what our goal is basically put all these terms together in the differential equation and compare the power of compare the coefficient of x to the power n. Okay, but you can see in this term x has a power of n minus 2. So we need to do the index shift and make it a term where x has a power of n basically. So now what we will do is we will only look at this term. Okay, so only look at this term. This term I'm keeping as it is. Okay, don't bother about it. So for this term, okay, for this term, let's take n minus 2 equals to m, right? So in that case, n equals to m plus 2. Okay, so this n minus 2 I am taking it as m, and then I can say that okay, n equals to 0 means then, so if n equals to 0, it implies m equals to, so if I put if n equals to 2, so the summation was starting from n equals to 2, so I want to replace that, summation limit also, so that's what I'm doing here. So if n equals to 2, then m equals to 0, and if n tends to infinity, then m tends to infinity. Okay, so that's what I will write here. So for the first term I am writing, okay, so only this term, okay. So it is sum over, instead of n equals to 2, I will write m equals to 0 to infinity. Okay, so n, instead of n, I will write m plus 2, and here instead of n, if I write m plus 2, then there is a minus 1 sitting here, so it will be m plus 1 a of m plus 2 x to the power m. Okay, so I am only taking this first term. Okay, this term I am only considering. So now you can see m is a summation index, so I can just write it like n equals to 0 to infinity. I just replace n by m. Okay, but this n is not same as this n. Sorry, this n plus 1, n plus 1, n plus 2, a n plus 2 x to the power n. Okay, so then it's basically, the first term is basically 1 minus x square times y double dash equals to sum over n equals to 0 to infinity n plus 1, n plus 2, a n plus 2 x to the power n minus this term. So n equals to 2 to infinity n times n minus 1 a n x to the power n. Okay, so we have calculated all the three terms in the differential equation, and now we will put them together. So let's put them together. So the differential equation is 1 minus x square y double dash minus 2xy dash plus l into l plus 1 y equals to 0. Okay, so if I put the values, so the first term is basically n equals to 0 to infinity, n plus 1, n plus 2, a n plus 2, x to the power n minus sum over n equals to 2 to infinity, n minus 1, a n x to the power n. Okay, so this is the first term. Now let's write the second term. Second term is minus 2x y dash, which is this one, right? So that is minus 2, sum over n equals to 1 to infinity, n equals to 1 to infinity, this term, n equals to 1 to infinity, n a n x to the power n, n a n x to the power n. Okay, so now let's write the third term, which is plus L into L plus 1 sum over n equals to 0 to infinity, a n x to the power n, that's the y equals to 0. So all these terms I wrote them together. Okay, so you can see all these in all these summations, x has a power of x to the power x has a power of n. Okay, but still we cannot put them together because here the summation is starting from n equals to 0, here the summation is starting from n equals to 2, here the summation is starting from n equals to 1, here it is starting from n equals to 0. Okay, so what we need to do is basically start all the summations from n equals to 2. Okay, but we cannot shift the index for that, because in that case x, the power of x will change. So what we will do is we will write this term. Okay, but before that no, I can write this. Okay, so I will write this term as, so I will write n equals to 0th term and n equals to 1th term separately. Okay, so if I write n equals to 0th term, then so this is 1 times 2. Okay, if I put n equals to 0, that is 2 times a2. Okay, and then x to the power 0, so that is 1. Okay, and so this is the n equals to 0th term. Now if I write n equals to 1th term, then it is, so it is 2 times 3, right? n plus 1, if n equals to 1, then it is 3. So 2 times 3 is 6 a 3. Okay, if I write n equals to 1, then it is a3, and if I write n equals to 1, then it is x. Okay, and then the other from n equals to 2 to infinity, all the other terms, n plus 1, n plus 2, a n plus 2, x to the power n. Okay, so I just wrote this term as this. Okay, so now for the second term we don't need to do anything because it is already starting from n equals to 2. Okay, so I will just write it as it is. So minus n equals to 2 to infinity, n minus 1, a n x to the power n. Okay, now let's take this term. Here it is starting from n equals to 1. Okay, so then what I will do is basically I will write, so minus sign, and I will write n equals to 1th term first. So n equals to 1th term means, So if I write n equals to 1, then this is 1, this is a1, and this is x. Okay, so it is then on 2 setting here, so it will be 2a1 x minus all the other terms, that is n equals to 2 to infinity n a n x to the power n. Great. Now let's write this term. So if I write n equals to 0th term, then it will be L times L plus 1 a0, okay, L times L plus 1 a0 plus n equals to 1th term, that is, so this is the n equals to 0th term, okay, and if I write n equals to 1th term, that is L into L plus 1 a1 x, and then I will write all the other terms, which is plus L into L plus 1 sum over n equals to 2 to infinity a n x to the power n equals to 0. Okay, so this term, this last term, which is basically these three terms. Okay, so it's a bit lengthy. Okay, so now what I will do is I will write the constant term separately. I will write so if I write the constant term separately, then so this is a constant term, this is a constant term. Okay, so these are the two constant terms. So if I write them separately, then it is 2a2 plus L into L plus 1 a0, okay, plus then I will write the term where x has a power of 1, okay, so which is linear in x. So this is one such term, then this is another, and this is other, this is other. So if I write them together, then so it is 6a3 minus 2a1 plus L into L plus 1 a1 times x. Okay, and now I will take care of the summation terms. Okay, so all these summations, you can see here x has a power of n, x has a power of n, x has a power of n, and all are starting from n equals to 2, n equals to 2 to infinity, right? So then I can put them together. So if I do that, then let me write a plus sign here, and let me write down this term, so which is sum over n equals to 2 to infinity, okay, n plus 1, so this term, I'm writing this term, n plus 1, n plus 2, an plus 2, n plus 1, n plus 2, an plus 2, okay. So this x to the power n, I will write it separately, no, because x to the power n is common in all these terms. So now let's write, so let's put these three terms together in this form. So if I do that, then what happens is basically, okay, so if I take minus outside, then it is n into n minus 1, okay, n into n minus 1 from this term, then this is minus n from this term. So if I have already put minus outside, so it is plus n from this term, and from this term it is minus L into L plus 1 times an, okay, and whole multiplied with x to the power n equals to 0. right? Okay, now if I simplify it, I think I'm doing it right. You can check it yourself. So okay, let me simplify it. The first two terms I'm writing it as it is. So it is 2a2 plus L into L plus 1 a0, okay, plus 6a3 plus L into L plus 1 minus 2 times a1, okay, times x plus sum over n equals to 2 to infinity n plus 1 times n plus 2 a n plus 2, okay. Now let me simplify this. So it is if I simplify it, then so there is, so if I multiply this n with this n minus 1, so it will be n square minus n plus n, okay. So it is n square minus n plus n, and this is minus L plus 1, right? So then this n cancels. I made a mistake, sorry for that. So okay, the mistake is let's go back to this step, okay. So here for this term which was starting from n equals to 1, so I wrote these two terms, okay. This is for n equals to 1. If I write n equal, so n equals to 1th term is this term minus 2a1x, okay, and all the other terms that I wrote here, okay. So n equals to 2 to infinity n a n x to the power n, but I missed this 2 factor, okay. So there will be a 2 here, good. So if I write this 2 factor, so then here also, so here this term, so it is coming here, like so an is here, x to the power n is here, and n, so this n is this n, okay. So in that case I need to multiply a 2, so here also I need to get write a 2 factor, okay. So write a 2 factor here, right. And here then, now if I simplify it, so if I take this term, so then it is if I simplify it, then it is, so it is n square minus n plus 2n minus L square minus L, okay. So now this minus n plus 2n, so this is just plus n square plus n, right. And now if I take this this minus L square here in this side, and then if I put my plus n here, so then we are left with, then this is minus L square plus n, okay. And now what I will do is I will write this n square minus L square as n plus L times n minus l. Okay, and here you can see there is one n minus l. So if I take n minus l common, then this term will be basically n minus l times n plus l plus 1. Okay, so I can write it as minus n minus l times n plus l plus 1 times a n x to the power n equals to 0. Fine. Okay, so let's look at this. So now what I will do is I will make the coefficients equals to 0. Okay, so that means I will put this equals to 0, I will put this equals to 0, and I will make this equals to 0. Okay, so this will give me the recurrence relation, because it will connect the nth term with n plus 2th term. Okay, so let me first look at this term. Okay, so I will make so what this term is saying is basically twice a2 plus l into l plus 1 a0 equals to 0, because this right hand side is 0. So it means that a2 equals to minus l into l plus 1 divided by 2 a0, or I can, instead of 2, I can write it 2 factorial. Why I am writing it? It will be clear if once I write the other terms. Okay, and in this side, then so if I take this coefficient of x equals to 0, so that then it will give me 6a3 plus l into l plus 1 minus 2 times a1 equals to 0, which gives me a3 equals to minus okay, I can simplify this term also. So this term is basically l square plus l minus 2, right? So I can write it as l plus 2 times l minus 1, right? So in that case a3 will be equals to minus l minus 1 l plus 2. Why I am writing it like this? Why I am not writing it like keeping it as it is? I am writing it like l minus 1 times l plus 2. That will be clear once I write the other terms, because it will follow a pattern. But divided by 6 times a1, and 6 I can write it as 3 times 2, right, which is nothing but 3 factorial. Okay, so this is one important term and this is the other. Now let me write down the recurrence relation. So that will be given by this. Making this term equals to 0. Okay, coefficient of x to the power n equals to 0, where n should be greater than equals to 2, because here n is starting from 2 to infinity. Okay, so for n greater than equals to 2, I can write n plus 1 times n plus 2, okay, a n plus 2 minus n minus L n plus L plus 1 a n equals to 0. Okay, and which basically gives me a n plus 2 equals to n minus L times n plus L plus 1 divided by n plus 1 times n plus 2 times a n. Okay, so this is our recurrence relation. This is our recurrence relation. What it does, is basically if I start from say 0, a1, a2, a3, a4, a5, a6 dot dot dot. So if one starts from a0, then this recurrence relation says that okay, if one starts from a0, okay, if this recurrence relation says that okay, this recurrence relation is valid for n greater than equals to 2. Okay, so if I should start from n equals to 2 then. So if I put n equals to 2, so then this term is a2 and this term is a4. So what it says basically is if I know a2, then this recurrence relation will give me a4. Now if I write n equals to 3, if I write n equals to 3, then this is a3 and this is a5. So it is basically says that okay, if I know a3, then it will give me a5. Okay, and similarly you can say if I write n equals to if I write n equals to 4, so then this is a4 and this is a6. So if I know a4, if I put a4, then basically says that okay, this recurrence relation will give me a6. So if I know a4, it will give me a6. Say 7. So and if I know a5, then it will give me a7 and some like that. So that's the job of this recurrence relation. Okay, so let's summarize what we have then. Okay, so you can basically see we will have two series. Okay, so let's start with a0. Okay, and the other series will start from a1, right? And this coefficient of x to the power 0, that is this one, making this equals to 0, is giving me a2 in terms of a0, right? So from there I can write that a2 equals to minus 2 minus L into L plus 1 minus L into L plus 1 by 2 factorial a0. Okay, so I know a0, I know a2, and now the recurrence relation will take care of the other terms. Okay, for this side a1, so making the coefficient of x equals to 0, I got this relation. So it basically gives a3 in terms of a1. Okay, so let me write it in blue. So if I start from a1, so then a3 equals to, so a3 is given by this equation. Okay, a3 is given by this equation, which is minus L minus 1 times L plus 2. Okay, L plus 2 divided by 3 factorial times a1. Okay, so basically I know a1. So if I start from a1, I know a3, and then the other terms are taken care by this recurrence relation. Okay, so what is then, so then if I put n equals to 2 in this recurrence relation, what I will get a4 equals to, so if I put n equals to 2, I will get a4. Okay, so a4 equals to n equals to 2, so that means 2 minus l, so equals to 2 minus l then times 2 plus 1 plus l, that is 3 plus l. Okay, or l plus 3 an, that is a2. Okay, one thing, let me write it as instead of n minus l, let me write it as l minus n and take the minus sign outside. Okay, so in that case this term is l minus 2 and here is a minus sign. Okay, and in the denominator we have n plus 1, which is basically 2 plus 1, that is 3 times 4. Okay, so 3 times 4, and we know a2, so a2 is basically this term. So what we have is basically minus minus plus l into l plus 1 times l minus 2 times l plus 3, and in the denominator I have 3 times 4 times 2 factorial, so that is 4 factorial a0. Okay, so this is the a4. So now you can see the pattern emerging. Right, so okay, for if I put n equals to 3 in this recurrence relation, I will get a5 equals to, okay, I will get a5 equals to, so if I put n equals to 3, then it is, there is a minus sign here, so minus l minus 3 times l plus 4. Okay, because n equals to 3, so l plus 4 times a3 and in the denominator, so it is 3 plus 1 times 3 plus 2. Okay, that is 4 times 5, and so it is 4 times 5. Okay, equals to, so this minus, if I write then a3 from here, so then this minus minus plus, and it is l minus 1 times l plus 2 times l minus 3 times l plus 4. Okay, and times a1, and it is in the denominator, there is 3 factorial here and 4 times 5, so 3 factorial times 4 times 5 is 5 factorial. Okay, this is our a5. Now you can clearly see the pattern emerging. Okay, let me write another term. So if I write n equals to 4 in this recurrence relation, what you will see is basically a6. Okay, a6 equals to minus l minus 4, okay, then l plus 5, so n equals to 4 plus 1, that is 5. Okay, so l plus 5 and in the denominator, so 5 times 6, it is 5 times 6 times a4. Okay, and now if I put the value of a4, then it will be minus, in the denominator it will be 6 factorial, because 4 is, there is 4 factorial times 5 times 6, so it is 6 factorial, and in the numerator we have l times l plus 1 times l minus 2 times l plus 3 times l minus 4 times l plus 5 times a 0. Okay, and here if I take n equals to 5, it will be a7 equals to, I can just follow the pattern and write it. Okay, so if I can follow the pattern and write, and you should check, so it will be l minus 1, then l plus 2, then l minus 3, then l plus 4, okay, then l minus 5, then l plus 6. It will go up to l plus 6, because for a5 it went up to l plus 4. Okay, and there it will be 7 factorial times a1. Okay, you should check it. Okay, I'm just writing it by following the pattern. Okay, now so interesting thing is, you can check that, okay, you can see that this minus sign is coming in an alternative way. There is minus 1, minus 3, minus 5 here, and here is minus 2, so l minus 2 minus 4. Okay, so it has importance, you will see, maybe not in this class, maybe in the next class. Okay, so then what we have is, basically we have two series. One is for this a0, another is for this a1. Okay, so if I put them together, or let me write here, that is y x is equals to sum over n equals to 0 to infinity a n x to the power n. Okay, which is basically a0 plus a1x plus a2x square plus a3x cube plus a4 x to the power 4 plus a5 x to the power 5 plus dot dot dot. Okay, and we got two series, so I will write it as a0 plus, so all the even indexed terms separately, a0 plus a2x square plus a4 x to the power 4 plus dot 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 plus a1x plus a3 x cube plus a5 x to the power 5 plus dot dot dot. Okay, and then if I write the value of a2, then a2 is this term. Okay, so I can take this a0 common, I can take this a0 outside, so it is 1 plus, or it will be minus basically, because in the a2 there is a minus sign, so minus l into l plus 1 divided by 2 factorial, so it is l into l plus 1 divided by 2 factorial times x square plus a4 is l into l plus 1 times l minus 2 times l plus 3, so l into l plus 1 times l minus 2 times l plus 3, okay, divided by 4 factorial x to the power 4 plus, there will be minus, basically you can see in the a6 there is a minus sign. Okay, and I'm not writing this in big term. Okay, I'm writing just dot 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 plus a1 I can put outside. Okay, so then it will be x, it will be x a3, so you can see a3 there is a minus sign here, so minus L minus 1, so L minus 1, L plus 2. Okay, L minus 1, L plus 2. Try to understand the pattern. Divided by 3 factorial. Divided by 3 factorial x cube. Okay, plus, so alternatively plus minus, and then I will just follow the pattern and write the term L minus 1, L plus 2, L minus 3, L plus 4. 5 factorial times x to the power 5 minus dot 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 all the higher order terms. So these are the two series, right? So this series, let me call it y0 x, and this series, let me call it y1 x. So basically our solution is y equals to, y as a function of x equals to a0 y0 x plus a1 y1 x. Okay, so these are the two independent linearly independent solutions, and the general solution is a linear combination. So these are the two linearly independent solutions, and our general solution is a linear combination of these two. So what we did in this class is basically we took the Legendre differential equation and we found out the general solution of it. Okay, and now depending on L, we will generate different solutions. Okay, so that we will do in the next class. So that's all for today. Bye.